So Marilee Wheaton is also a SERC Fellow, completing her PhD at USC in the Systems Architecting and Engineering program. She's the 2020 INCOSE President-elect and currently a Systems Engineering Fellow at the Aerospace Corporation. In this role, she is responsible for providing technical leadership and building capability across the corporation to include digital engineering, enterprise systems engineering, systems architecting, and model-based systems engineering. Marilee is also a fellow of the American Institute of Aeronautics and Astronautics and is an active member of the organization's technical committees on economics and systems engineering. A fellow and life member of the Society of Women Engineers and a past president of the LA chapter, Marilee has taken on high-profile leadership positions for SWE, both locally and nationally. She's also a member of the IEEE and an active member of the IEEE Systems, Man, and Cybernetics Society. Today, Marilee will be presenting her work, transforming historical cases into dynamic simulations to generate new insights. So with that, I will turn it over to you, Marilee.
Very good. Thanks, Kara. Can everyone see my slides? Are we good?
That's great.
All righty. While I'm in presentation mode, I won't be seeing the chat, but I'll go to the chat at the end of the presentation and look for any questions. So I'm currently pursuing my doctoral degree at USC under the guidance of Professor Azad Madni. And I'm a student in the Astronautical Engineering Department, which has a systems engineering track that is led by Dr. Madni. And so over a year ago, Dr. Madni posed a question to me, and it was, how can historical knowledge that is captured in cases be made more insightful, dynamic, and actionable? And he shared several papers that he had written. One was on ontologies, another one on interactive storytelling, and one on experiential dashboard, all of which are very seminal papers in systems engineering. And I really took this question to heart for my research because I felt that if we could answer this question, it really had practical utility to the systems acquisition and engineering community. And it also required a multidisciplinary solution to the question. And so that was kind of the evolved journey related to my dissertation. I'm currently about set to take my qualifying exam. So I'm very happy to be presenting where I am on my research here in the next 20 minutes. And so I'm going to share my research objective, and then I'm going to highlight some key elements of the approach and then get into the expected outcome. So this is the outline today, where I'll cover the research objective, talk about the approach, and then end up with some way forward and next steps. So as I mentioned, the question for the research had to do with historical cases. And so if we look at historical system engineering case studies, we see that they produce limited insights. They're static to what happened during that time for that case study. And so we really felt they were not adequate if you want to train new program managers in planning and decision-making. But we realized if you could simulate those historical cases and allow you to change some of the assumptions or constraints or decisions that were at that time, then we could potentially produce different case outcomes, which would expand the value of those case studies. And then we could also look at sensitivities related to some critical factors that we've identified. And the thought would be that by creating those insights, we could help to accelerate the training for new or inexperienced program managers. So the research objective then was to develop this modeling and simulation-based approach where we can explore those historical cases and then enhance the value of them and thereby to accelerate the learning of these program managers. So certainly a model-based approach, but one with practical application, I believe, to the system engineering and so as an overview of the methodology, leverage quite a bit of previous research. Certainly the study related to case studies and those historical records exists. Ontology, as I mentioned, one of the key papers provided by Dr. Modney had to do with the use of ontologies for systems engineering. The dashboard technology, which I'm using, comes from the paper that Dr. Modney presented on experiential dashboard, and then combining that with a model-based simulation approach allows us then to generate these alternative cases and the evaluation, and thereby resulting in additional case study outcomes that can be saved and then queried at a later date. So a little bit more specifics about the methodology overview. So I did develop some use cases of interest to stakeholders for a particular system of interest. I'm using small sats and CubeSats. And then I've combined the dashboard technology, this ontology-enabled case representation, and then looking at the sensitivity and cost analysis related to that. So I'm using the dashboard to allow for visualization of the outcomes of the cases, and then using these historical case studies for some proof of feasibility, and then also looking at the data analytics through the dashboard to show the impact on data as we do some sensitivity analysis. And so I'm going to demonstrate the research through these representative case studies, and then show that it really does have a potential impact on stakeholder insights. This is a diagram of the top-level system concept and how the user interfaces with the system. I'm using Excel for the data entry, and also actually for the simulation and the visual dashboard. Excel has got a lot of capabilities. It is widely used in the system engineering acquisition community and widely available. So as parts of the system concept, you have the areas where you're going to define the cases, be able to update them. All of that information goes in the case repository. Any of the what ifs that you do can also have an audit trail related to capturing those outcomes. You can analyze the results and see what's happening on the dashboards, and then look at these visualization perspectives through the dashboard that gain you the insight to the system engineering and acquisition community that this is trying to provide insight for. So speaking of platforms and tools, I did look at various options. Obviously, if you're thinking about doing simulation, there's tools, AnyLogic, MATLAB could be used. I looked quite a bit at Excel, and I ended up choosing Excel because it did have the functionality that was needed. It was very easy to use, and of course, it has wide applicability. So that was my tool of choice for this research. Another area that I needed was the parametric estimating equations. This comes from research also done at USC in the Center for Systems and Software Engineering under Dr. Barry Boehm, who has also been one of my advisors. And so I'm using actually parts of the COSISMO system engineering cost model in order to obtain that relative cost sensitivity when we change certain assumptions related to the case studies. And then, of course, the dashboard is also implemented in Excel, and I do have an example of a dashboard in this presentation. As I mentioned, I leveraged the work on ontologies. So ontologies, of course, are finding increasing use in systems engineering. The elements of the ontology can serve as metadata for the cases, and so therefore, when you have this ontology representing it, it makes for a much easier retrieval from the database of case studies that you might have. And the other, really key things about establishing that ontology is it helps with the reasoning and collaboration. You have the common terminology, and then that allows you to have a shared understanding of terms among stakeholders, which can be really important for those insights they need. And then also you can the responses to the user queries can be stored because it's stored along the ontology with the metadata and allows for easy retrieval of that domain knowledge. So that ontological representation underpins the research. Here's a top-level ontology for the model-based analysis. So, of course, any historical case has key events and key decisions associated with it. There were certain entry criteria for that case. It has a timeline in which that case evolved, and they also the context that you need, which of course influences that case. And then you've also got the constraints and assumptions that become part of the context. And so it's in these areas that we're hoping to look at sensitivities for trade-offs. So by looking at the sensitivities around either those entry criteria, decisions that were made, constraints, assumptions, results in different outcomes from that original kind of static case that we looked at. So again, this is a top level ontology. As I mentioned, the SMART experiential dashboard is a very key part of this research that I'm leveraging. You'll see in the reference section the original paper that Dr. Mani did in 2016, but it really allows us to capture and visualize the execution of the simulation and also what the sensitivity of the outcome to those parameters is. And it kind of allows us also to visualize this multi-dimensional problem space in a way that then, folks that are using it, that look at it, can have those insights. And so, as we change any decisions and assumptions that went into these cases, it allows us to visualize what the impact is. And you'll see that we also can diagram those using a Kvyat diagram, which is a key part of the dashboard. And so the dashboard really allows us to look at those changes in parameters and then therefore provide additional insights to folks that might be looking at future acquisitions, system architects, system engineers, as they explore future decisions. It provides that body of knowledge that helps hopefully accelerate folks that might be new in this domain in terms of having to be a system engineering manager or program manager for acquisition. So here's an example of the dashboard. This is kind of full and busy, but let me walk you through some of the parts here. So what you see is on the left side of the dashboard is these are some of the areas that we could do sensitivities on. So things related to the socio-political complexity, the design complexity, or the technology risk. And these sets of parameters here, I'm drawing from the COSISMO model. That's the other USC research that allows us to look at changes or sensitivities and then measure the impact. And you also see over here on the right, part of the dashboard is looking at aspects related to the risk resolution of any particular case study and allows you to change assumptions from the original case study and then applies a weighted value to that. And therefore you can look at the sensitivity of that parameter as well. And as you see, then you can get a relative impact in terms of the cost profile and or the schedule associated with that particular case study. And then the Kvyat diagram over here allows you to show for multiple instances of the changed assumption you're looking at, what does that do in terms of the key parameters you're looking at, how do they change? So it allows you that quick look on that. So again, this would be one of the dashboards that we would use that would allow folks to both change the parameters, enter them, see the impact, and therefore on any specific case study, look at a lot of different potential outcomes and the sensitivity to those outcomes. As I mentioned, the exemplar application I'm using are small sats, so that's what I'm using for my illustrative case study and validation. I picked this because in the domain in which I work on, mission capabilities are really being augmented by these smaller sats, or both augmenting existing capabilities as well as providing new capabilities that are available on a very much shorter acquisition and development schedule, and also a lower cost as compared with existing programs of records. Now, of course, from a performance perspective, they are has to be compared with what we've done to existing larger systems, but they definitely do provide capabilities that are increasingly being used. And also in the defense area, they're actually looking at commercial applications that might augment capabilities as well too. And then of course, in addition to small sats, CubeSats are also being utilized as prototypes to try out a certain technology. So again, very quick, try out a technology. And so there are examples, case study examples related to small sats. And so I'm going to use one of those to demonstrate the use and the value proposition that you really can, by using a model-based approach, have these case studies be more dynamic and therefore serve as an experience accelerator for these program managers. And the thought is that these model-based case studies then are able to be explored in terms of decisions and assumptions made, and therefore, and also visualized using the dashboard. Some of the use cases that we've identified that we'd like to explore using the notional small sat case study have to do with things such as schedule, increase or decrease in performance capability, looking at the design complexity. Technology readiness is also a key area where, you know, you freeze that technology at a certain time. There's risk involved with that if you want to try to reach a higher technology readiness level. So how does that affect the desired outcome for performance? And so even though we're doing this framework and using the exemplars of small sats, this framework could actually be used across a much wider variety of cases because it is developing the methodology and we're just exploring its use through the small sat, but again, could be used with other use cases. So as far as expected research outcomes, we've defined the framework and methodology for this what-if analysis using historical cases. We have the case study ontology that enables us to integrate those case studies. That's going to allow for the easy search and retrieval as we save the different outcomes based on the model-based simulation. And we've also looked at the methods and processes that will analyze those sensitivities. We're going to demonstrate the impact of those dissension assumptions, and then also use the dashboard for visualizing the models and the what-if analyses. So these are the expected research outcomes. And as I mentioned, I'm going to be soon be taking my qualifying exam, and then I'll be continuing on with the development of this research. So the accomplishment to date for the research is I've developed the case ontology. I've developed those exemplar scenarios that we're going to use. The methodology was created that allows us to transform those cases into the simulations using those ontologies, and then created that dashboard prototype in Excel that allows us to visualize and control the simulation execution. So the next steps is I do need to implement, therefore, the overall approach. I am going to apply it to one or two historical cases to demonstrate that indeed we can enhance the value of those historical case studies and look at alternative outcomes. I'm going to catalog those new insights into our case knowledge base. And of course, I have to develop documentation for use of the approach and tool. And I have been initially publishing on this research. Last year at the IEEE Aerospace Conference, there is a paper that exists that describes this, and I'm currently working on another paper that fully documents where I am now with that research that will be published either in NCOSE, IEEE, or potentially CSERC conferences coming up next year. So in summary then, I've been conducting this research under the Astronautical Engineering Department at USC. I am a SERC fellow, as was mentioned, and I will highlight or foot stomp on Tom McDermott's point about if folks are out there doing research at one of the partner universities for SERC and would like to be a fellow. I think it's a great opportunity. It allows us to present at this forum, and there's a lot of value in that, and also getting feedback. In fact, it was at a previous forum a couple years ago that I presented that I got a lot of guidance in terms of the scope, which was really too broad at that time, which always, of course, happens when you start research. And so I really took a lot of the input to heart. And that's why in the last year, we've really scoped it to something very specifically. We feel that meets the objectives for PhD research, but also is something that we can actually get done. And so, the premise is that these historical records have a source of knowledge that could be further tapped. We're using the ontologies as a means to organize all the knowledge associated with those cases, and then using the simulation to explore the different assumptions on those cases, and thereby resulting in these new insights that then take that one case study that's very static, makes it inherently more dynamic, and therefore then by exploring what some of those alternatives are, can help decision makers in terms of making future decisions, going forward for programs. And so I really believe the research that I'm doing will be a contribution to the body of knowledge in MBSE, case studies, and also in model-based analysis. So I do think that it provides a promising solution to the systems acquisition and systems engineering communities. I believe it'll be useful to my company, the Aerospace Corporation, that has been supporting me as a SERC fellow. And I think also it provides a new way of exploiting historical information on systems acquisition and systems engineering program. So that's the summary of my research, and I do have a chart with the references for these papers that I mentioned. And if I go off of, I should be able to see the chat and see if there's any questions here. Okay, so question from Marilee. Okay, some from Beth, I think is the first one, right? Yeah. Hi, Beth. Glad to see you, hear you. Did you find that you needed to set constraints on how the case studies were developed in order to be included? I've found curating case studies from our classes to be difficult. Some are written in detailed deep dives without conclusions, and some are written as self-serving reports. Yeah, good point. The quality of case studies does vary. There are aspects of case studies that say are well developed. I know, for example, there's many that are done by NASA that are documented, where they do kind of have the full set of information. As part of this research, we're really kind of taking a notional case study that would have all the entities that we're interested in. But you're right. I think in terms of some case studies, you wouldn't have everything. But the nice thing about that, though, is by using this framework, you could make assumptions about those areas that were missing with that case study and see what the impact would be, right? So even if you're missing certain data, I think it still would be helpful to do the simulation. But we are, as part of the research, looking at case studies that in some sense represent the full set, so we can actually try out the full methodology. But very, very valid point. And from Tom McDermott, have you also looked at some cross-domain cases, i.e. what small set problems and solutions can learn from similar and different domains? Approach to use TWIS and domain-driven. Yeah, so we picked the small set, but hopefully you can see from the framework that we've developed for the research. I mean, you could develop a, for other use cases, then have the representative ontology with the metadata that you need, set that up, have that available, and then do the same process, right? So you would look at the, but based on the fields from that ontology, then populate the research that way. So I really believe it has broad application. It's just, obviously I'm most familiar from working in my career in the space industry. So I wanted to pick something notional that I really did understand all aspects of what it might entail. And therefore then that would assist with the research, because it's coming from domain knowledge that I know. But I agree, Tom. I think that it could definitely be used for other cross-domain and, hopefully potential other research that could be done that it might extend it to other domains as well, too. So I want to thank everyone for being able to present here. And I'll also, if there are any other questions, I'll keep watching the chat. And if there's anything, I can respond to questions in the chat. So thanks for the opportunity.
all of our SERC doctoral fellows this morning for presenting. Giselle, Sean, you as well. It's been a great morning session. We're going to move to the lunch break for us here on the East Coast. And we'll resume back at 1:15 for session 2. So thank you, everybody.
Bye all.